Alright, hello YouTube. We're back for another Ethereum IoT tutorial. We're going to incorporate a switch. Oh my gosh, we're getting that human interaction in with the IoT device, and we're going to communicate with the smart contract through the Web3 library. But yeah, why would you want to do that? I don't know. But we're going to do it. I'm thinking more or less eventually you're going to make an ERC20 token, and we can use this switch to basically be a centralized kill switch on the coin. So yeah, what do we do with this wonderful blockchain decentralized technology? We put a kill switch on it. So just to go back, reminder, GitHub link is in the description, but you're gonna need a few prerequisites. It's pretty timely to get these things, or time consuming to get these things installed. I'm not gonna go through a whole lot. So that's your Pi with the NodeJS, the Ethereum testrpc, which we run locally, browser Solidity, which we compile our smart contracts and deploy to our testrpc, and then the Web3 is actually going to be on the Pi with our Node.js. So these these are on the Pi, these are running locally. For the switch, we need a library to communicate with GPIO pins, and that's this one right here, rpi GPIO. This depends on another package which I needed to install before I even got anything working. So that was the EPOL library. For some reason I needed to get that installed before I could properly access the rpi GPIO. So without further ado, we're going to work on the switch example, and what I have here is basically my Pi mounted, and this is so I can use the Atom text editor here. However, because the text editor doesn't actually have any access rights, and our node program is trying to use the GPIO, it needs to be run with the root access relative to the actual device. So for that we got a SSH in. So the way I mounted this file system though was using SSH file system. It's just a basic little bash script there, but to show you, oh yeah, so we're going to SSH into our device, and the directory was right about here, and we're going to start our example, and it should actually break because there's nothing there yet. So actually what I want to do is we're on branch switch example. Alright, we're going to make the switch example directory, and now that we're here, we're gonna touch, and I'll get back to where I want to be here. So in our actual module, basically we're using it to wrap our apps. So on the very least, this module needs to be a function. Sorry, it needs to be a function that takes in the app and basically wraps it and returns it. So whatever we got to do to our switch example, we got to do here. I'm going to ignore that phone. Whoops, I don't want that. High switch. Okay, we're picking up where we left off. I'm getting all sorts of distractions and interruptions today. It's been difficult, but basically we're taking this example right out of the RPi GPIO. We're going to actually watch for a change event. So the way we're going to do that is first import the library. Whoops. And we're going to need a variable. Now I have my switch already set up. I'll do a little picture somewhere around there. But I found the GPIO seems to float high, so you can actually avoid a 3.3 volt power to it just by just pulling the pin low to ground. I'm finding that that's working, so I'll show you that setup real quick, but this is basically what's up. In our application, we need to set up the pin, and then basically we're going to watch for changes. Now this isn't a true asynchronous kind of event change. I'm pretty sure the library pulls and watches the pin about 5 times a second, so there's probably some performance considerations that especially since we got like 17-second block times, like yeah, we don't need to be really looking for changes every 15 seconds, twice a second, but whatever, we're just gonna use this for now. And we're going to walk over and hit that switch. So one thing we can see is that it's triggering the well, when the button's depressed, it goes low, and when it's up, it goes true. So it's triggering both the edge rise and the edge fall. That's kind of as indicated by here. But I guess I want to trigger really when it's first depressed, right? So for example, if channel, so we are only listening to our one channel, so we need to make sure that the channel is basically equal to the input we're looking for, and we only care if that is going low. So if value is equal to false, we're going to be triggered. Something like that. So onward to some Web3 contract stuff here. So I'm gonna need to open up the RPC client. Oh, actually, let's just see if this triggers as well. So when it goes low, it triggers, and actually what we're going to need to do is have a state variable on our app called triggered, and we're going to set it equal to false. But when it is triggered, we set it equal to true, and we basically can't trigger until we reset that back to false. This is going to take care of our refractory period. Now we could just make it deterministic, like 17 seconds the average block time, but then you might, we're gonna, because we can broadcast an event from our contract, we're going to wait to hear from that, and then we reset. So as long as this is also equal to false. So we can only trigger this thing once, and only once. We're going to need to import Web3, but we don't know what we're doing with it yet because we don't even have our contract made. So as I mentioned, we're going to get over here. This is my local machine here, and we're going to start the RPC client right here. Actually, what I'll do is, because both of these things are local, I'm going to tmux this. You'll probably want to go through a tutorial on tmux yourself, but we start the RPC here, and over here I'm going to go to where I got my browser Solidity set up and run our Solidity server here, compiler. So now that that's loaded, we can open up the browser compiler. And as mentioned before, if I were to, that start RPC script basically has a seed mnemonic so that we always start with the same available accounts and private keys. Showed that in the last video, and I'm gonna close this switch example here because I was just working on that. That's basically what we're doing. So the Web3 provider is connecting, and once it does connect, it should make a bunch of requests to our RPC, which is down here. There it goes. So we got this one account right here. So I guess we'll make a new contract, and I'll call this switch. I guess I got switch faucet and all that stuff in there, but switch. All right. So what's different about this example is we're going to need to, I don't want just anybody to be able to switch this on and off, so we're going to need to define the owner of this contract. So here's my switch contract, and I guess to do that we actually have a constructor, which is called when this contract is declared. So an address is basically a data type in Solidity for the hashed address, the public key, and we're going to call that owner. But when this thing is created, we're going to set owner equal to the message.sender. Each time there's a transaction, there's a value in the sender, and that's basically what would be in here. Account is the sender and value. So whenever there's a transaction being made, that's the kind of information that's immediately available on this message variable. And already we got something basic here. I guess we need a capital letter for our contract name. Given that, let's keep that consistent. So what do we got here? Well, we need our actual switch. I'll call it the switch, and essentially the switch needs to be default to false. Now I guess we've got our getters and our setters, and I guess events, but we're also gonna do something neat here called a modifier in 1 minute. Let's just write the getter though. Anyone should be able to see the switch we'll call that get switch, and it's a constant, and it returns bool value, and I'll just call it switch state. When it's returned, and essentially this just returns the switch. Now we need to be able to switch this switch, so hence we're going to have a setter in here. And instead of setting it to a certain value, I just want it to toggle from whatever it was to wherever it may be. Basically, doesn't return anything, and it doesn't even take in anything. So what we need to do is basically take the switch, set it equal to the opposite of whatever it was. And basically when these switch events occur, we want to fire one. And then I guess we have Boolean new state. And we fire that event when the switch is toggled. Switch event, switch event. Okay. Whoops, there we go. I have to tell it what type of thing this is. Alright, well so far this is what we have. We can deploy it, but anyone, just anybody, can toggle this switch right here. So we're going to look at an important primitive type in Solidity called a modifier, which is basically like a middleware for your functions. So as the Coinbase wallet, which is this first one here, we can toggle the switch and set it to true. But anyone else can turn it false. So for example, this person, and they can toggle it as well. I don't want this to be the case. I only want me, the owner of the Coinbase Genesis block, to be able to switch this thing. There, I fired the second event there. So in order to accomplish that, we need to put something in called a modifier. And I guess we're going to call this one only owner, because only the owner is allowed to fire this thing. Now I'm going to put that in there just by default. So right now this modifier does nothing. What we're doing here with this underscore is that it basically is like returning the control flow back to the original caller function. In that case, it just returns. It's like the next in an express middleware, I guess, on NodeJS. But that basically allows us to go back. So toggle switch should only be called by the owner. But how do we tell if someone's the owner? Well, we want to use an assert statement then. Instead of using ifs, it's a little bit, I guess, standard practice to use asserts and reverts, assert statements. So here we got to assert that the message.sender is equal to the owner, right? Whoever's sending this needs to be the owner, and then and only then they can toggle a switch. So that's all we got to do for that. Let's create this contract again. Switch is false. Owner toggles the switch to which is now true. Someone else comes around, wants to set the state to something else. Doesn't work. Alright, so that's basically the functionality we want in our contract. So we're going to need the address. And we're going to need the ABI interface string in order to interact with it. So let's take that as well. So we got those two things. Alright, so we're gonna import the Web3. Now that this contract is deployed, I don't even think I want this running anymore. I'm going to include this with the Git repo, but I'm going to close this mainly because it really pounds the RPC. So if I close it, all these requests for all those different wallet balances kind of stops here. Alrighty. So now that that's stopped, we're going to work on the Pi here. So we import Web3. When this thing triggers, we need to send an event. So I guess we should define our contract and connect to it before this. So right in here. So we can say const web3 is equal to new web3. I've seen it done like that with new web3 dot providers. We can do something like this. And this is not running on the Pi, this is running on this machine. So that ought to connect this no problem. So some important things we're going to use, I guess. The Coinbase is the web3.eth.coinbase, and default account balance equals web eth.get. So right now this gives us the Coinbase, which is basically that 6868 first wallet, which actually created the contract that we just made here, and that's that. So actually I'm going to do some other important setup stuff right now. Now I do believe, okay, actually this will be cool. I'll make an error and I'll show you why, but I'll address that now. So this is the address of our contract. So I guess contract address, right? And that's the one. Oh, I closed the Solidity compiler, so hopefully it doesn't change and our RPC stays online and doesn't. Hopefully I don't have to redeploy the contract. Is all I'm saying. So our application binary interface is going to be the JSON object after it's parsed from what we got here, and it's just a little finicky. You want to wrap it in either the single quotes or your template literal apostrophe quotes, but that should work. So this is our switch contract. And web3.eth.contract ABI, and it is at our contract address there. So I'm just going to console log just to make sure we're connected, and we're interfaced with our contract. This won't work. Do it like that. What's happening here? So looks like we have our switch event and we got toggle switch. So okay, picking up where we left off, our switch contract has this switch event that it's listening to, and it also has the setter toggle switch. Now our Pi needs to be associated with a wallet, and in order to do that, we need to associate a default account with this Web3 instantiation, and essentially by doing this, this is associating the first account, or the 0th account, which is the Coinbase, with this Web3 instance. So with that, you can actually fire the toggle switch statement then. On top of that though, we want to listen to when this fires. To mind you, if you watch this setter right here, it's firing the switch event. So we're listening to that. And in order to do that, this is just similar to the last tutorial. We have switch event, which takes in an empty object and a callback function. And basically, we're checking for an error. And if there's no error, we're just going to print the message. Alright, let's see if this works. There's the block. So we switch the state to true from our IoT device. We can verify that over here, and here's the event that got fired. If you go to get switch, it's now true. And also the refractory period worked. App.trigger didn't. Oh, actually, so I can't trigger this again until we reset app.triggered. So in the case of a success, I want to reset the trigger over here. Here's the RPC. that switch event was mined in block number 25. Alright, so now that we got our smart contract interacting with our Raspberry Pi switch events, I guess that's pretty much it. I'm just going to get back onto the master branch so y'all can check out this episode on my GitHub. Also, please remember to like and subscribe. There's going to be another video after this. We're going to make an ERC20 with a kill switch. Alright. So be sure to check that out.